Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Moon to Earth Sling Out to Mars video series that I'm doing. Again, this is not going to be a full mission. I'm just explaining the setup process and how to execute this flight. Once we've completed the ejection burn to go out to Mars, then everything from that point forward is just standard Earth to Mars stuff. There's nothing new about that, so we don't really need to worry about all the actual trip from Earth to Mars and mid-course corrections and landing on Mars. All that is that's all just standard stuff. The tricky part is setting up the flight from the Moon down to the Earth, and then once you get to the Earth, how do you do the ejection burn to actually go off to Mars? And that's where we're at right now. So if you're following along with this video series, great. If you happen to be finding this video for some reason as your first one, this is actually part 4, so make sure you go back and watch the first 3 parts first, otherwise this isn't going to make any sense. Let's go ahead and switch camera views here, pick up where we left off. We're about 1,200 seconds away from the time to do the burn, and we need a lot of that time, so let's go ahead and get started. I'm going to bring up IMFD on this side. We're going to go to the menu, and we're going to go to course, and we're going to go to target intercept, and we're going to target Mars. And for the MJD, we're going to put in the MJD that we get from Transx in Stage 2, which is the encounter MJD of 58498.1401. That's what we want. That's what we want here. And we can just press set 58498.1401, and now we're done with Transx. We don't need it for anything anymore. But what I will do is I'm going to jot down that eject date, because a lot of times I have to reset something in IMFD and then I forget what the eject date is. So let's write that down. 58498.1401. We don't really need all those decimal points, but we'll have them anyway. Now that we have that, we're basically now just setting up, you know, a standard plan for going to Mars using IMFD. Now, again, I don't do this every day, so let me think about things here a little bit. Now we want to set the TEJ. We're going to go forward with the TEJ just a little bit. Again, just give me a second to process everything. Change the projection. Okay, so once we have the MJD set, we're going to bring up interplanetary MFD on this side also, and we're going to bring up the orbit eject program, and we want to actually share this side first. I forgot to do that with this side, so 1, and we want to connect the orbit eject program to the course program. So instead of being higher orbit, we want course. And now we can, there's a few steps here, so just allow me to think, please. We're going to set the TEJ to 0 because it starts off at 876,000 seconds. That's way too much. What we actually need is we just need the TEJ to be like, you know, in a few seconds from now. So we can probably go to a 10x adjustment, and we can swing that forward slowly. Watch that blue line, and what we're looking for is the minimum DV. Now we're going to go down to a 1x setting. So whenever the DV is at its lowest, that's how we know we've got a sufficient TEJ. And ideally, in a perfect world, it will be when we're right there at periapsis. But that won't always be the case, and it won't always be the case because sometimes you're burned. Sometimes you don't arrive at the Earth at quite the right time, which means you didn't leave the Moon at quite the right time. But it looks like we did okay here. So the DV is lowest right at that point. Now I want to check the EIN, and the EIN is showing that it's negative 0.05. We can adjust the EIN by changing the MJD, the arrival MJD, on the interplanetary on this side. So we're going to come over here to the TIN. We're going to go to a 10x adjustment because this is a kind of like your hyper or alter setting. So if we leave it set to 1, then it's going to be too small of a change. So we're going to go to 10. And we're just going to bump it forward or backward until the EIN is 0. Looks like, let's see, we can even go to 100. Okay, now it's down to negative 0.01. So let's go down to 1. And then continue adjusting till the EIN is exactly 0, 0, 0. And let's even go 10. All right, there we have it. Okay, so now we have that part set up. And let's see if changing the TIN, let's see if that had any impact on our delta V here with regards to the TEJ. I don't think it will, but let's just check. So let's go forward a little bit, see if it comes down any. It's not. So it's still where it needs to be. Okay, so now what we have to do is this is a little bit of a tricky step here. We're going to go to menu on this side, and we're going to bring up orbit eject over here. So we now have orbit eject up on both sides. Now this instance of orbit eject contains all the data, whereas this side is shared with this side. So that means that this is like the master IMFD now. This is the master version. So now we can come over here to this side. We can unshare it. Right, he's doing that. Then we go to the course program, then come down to the delta V set, and we basically now want to copy our orbit eject plan over to our delta V plan. Start by setting the TEJ to what we have here. So set, let's go 865, enter. Now we'll come down here to the velocities. Now the velocity that we have here, 605, that's our total. But our total is going to be a combination of prograde, outward, and plane change, and we don't know what that combination is. Since our EIN is 0, it should have almost 0 plane change. But we can know for sure by pressing page and coming over to the burn vector view, and we can see that our delta velocity, in this case, it's basically all prograde. So in fact, we can just enter it all as prograde. We don't even need to worry about that 1.46, and you can see that's actually going down, because the closer we get to this point, the lower these numbers are getting. So we can just put it all in as prograde. So set 605, and I'm looking at the total, 32. Now we're done with orbit eject on this side. So we'll go menu. And now we need to share this side with that side. So it's share with 0. Now we'll bring up the map program, make sure we're referencing the sun. Now we're going to target Mars. And we are going to turn off auto zoom, turn on display, page over, turn on the SOI, turn on the plan. And now we have an indicator as to what this is going to do for us. So we can come back. We can switch the pages back over to this page selection, press select to bring up Mars. And according to this plan, we would be missing Mars by 1.4 gigameters. That's quite a bit. So let's refine our plan here a little bit and bring that down to the surface. So TEJ, that's where we want to start. Make sure it's at 1x. And let's see what happens if we do the burn a second or two later. It's making it worse. So let's do the burn sooner. And you can see that's bringing the PEA down. So we'll just keep doing this. We'll keep bringing this down until this number reaches its lowest point. And then once it reaches its lowest point, we're going to add in like we're going to take away like 1 or 2 more seconds. So 87, that's still coming down, still coming down. Now it's going back up. So we went from 76. Now when I take away time, it's going up. So we actually want to just maybe add a takeaway. That was 1 second, so 2, 3, 4. Let's take away 4 extra seconds. Now we'll come to the delta velocity, the forward velocity, prograde, and we'll do plus or minus and see what happens here. So plus is not helping, so now we'll go minus. And remember, 76 was the lowest that we saw before. And let's... So now actually 80 is the lowest that I'm getting. So I'm going to actually go to 80, and I'm going to come back to the TEJ, and I took out 4 extra seconds. That might have been too much. So let's add in 1 more second. Actually, it looks like we're going the wrong way, so let's take out some more time. No, 80. See, it gets a little confusing, so you just kind of have to do some guessing games here. So let's take out another second. Take out 2 more seconds, in fact. Now let's do a little bit more of an adjustment on the prograde. Okay, let's go back to the time. 79, 80. Let's go back to prograde, and I'm just kind of guessing. Sometimes I can't anticipate what to do here, but sometimes I can't, and in this case I'm not able to anticipate what I need to do. So plus on the time is helping, and plus on the prograde is helping. So in theory, if I add a little bit extra prograde here to raise the PEA, now I'll come back to the time. Now I'll add in a little bit more time, and in theory it should be a lower number overall. 70 is still the lowest I saw there, but I'm going to add in a couple more seconds out to 94. Now add in some prograde. Now we're down to 68, 77. So it's being a little stubborn. Usually I get better results than this, but it's coming down. So, all right, let's add in 1, 2, 3 seconds. Now let's add in some additional prograde. I saw 61. 56, so it's working. So we'll add in some more time. And we'll add in some more prograde. 56, 57, 49, so it's still coming down. So add in some more prograde. 45, 39, okay, it's still working. 45, I don't believe I saw a lower number there that time. 45, 37, okay, I did see a lower number. So 45, and you just want to make sure that each time you go back and forth between the variables, it's always, you're getting a lower number overall. If you're not, then you're doing it wrong. So P8 is now 28. So now we're going to add in some more time. And actually that's not a bad thing necessarily, because we're getting closer to the periapsis. So that means we left the moon like at an ideal time. So I think 28 was the lowest I've seen so far. Now 22. 28, let's add in some more velocity. Back to the time. I saw 18. 15. 24. Now, when you get down really low like this, you want to make sure you don't overshoot by too much at one time. Just overshoot by 1 second and overshoot by 1 extra delta V at a time. So 23, 13. Okay, that's 1 extra second overshooting. 12, 21, that's 1, probably go 2 on the delta V. 11, 31. 10, 18. So we're getting really close. And again, the target altitude is about 2 or 3 kilometers below the surface. It's down to 9. Now it's getting pretty stubborn. We may have to use a little bit of inward outward, but we really would like to not do that if we can. But I'm not getting anything better at this point with just by adjusting time and prograde. It's not improving anything. Well, there we got 8. But so we'll continue with time and prograde as long as we can keep going lower. And we're still beating it. So let's just keep up this trend. Okay, that's 4. So 1 extra delta V, and then 1 extra second. That's getting really nice. Okay, so we should be able to get this just with prograde. If possible, get it with just prograde and time. I've had a bad habit in the past. I give up too quickly on prograde and time, and then I start relying on plane changing inward and outward, and that gets expensive in a hurry. So if you can, just do this with time and prograde. So now we're down basically to the surface. So let's add in 1 more second and prograde. Now we're below the surface, and that's what we want, but that's not quite low enough, although it is trending downward, but we'll go a little bit lower. So 1 more second, and there we have it. That's what we want when we go to Mars. We want something negative 2.5 or more. Anything up to negative 3,000 is good. And then watch kind of what's happening. You can see it's dancing around as we're getting closer to the Earth, because I think it's probably because we're not in a perfectly circular orbit. then this isn't holding really well. But we're getting around now to the time to do the burn. And that's basically it. All we have to do now is page over to this page, and we can optionally bring up the burn vector, and then AB, and warp time forward. I would watch it though, since we're still 300 seconds out. I would watch to make sure that your PEA doesn't change, doesn't suddenly jump up to 10, like positive 10M, which can happen in some cases when you warp time forward by more than a few minutes. So as we get down to really close to do the burn, 120 seconds out, like right now, I would say if this has suddenly changed out to positive 10M, then what you can do is just go back to this page and then just on a 1x setting, maybe add in one more second or take away a second, or add in one more delta V or take away a delta V, whatever you need to do to bring that back down. But it's fine where it's at, so we're not going to mess with it. So burn vector over to this view, and then we're going to warp time forward and let it handle the burn. Once the burn gets underway, you want to change back over to this page and turn off the plan. In fact, we can even do that now. And then we're going to watch the PEA here at Mars for when the burn is actually done. It's going to be done here in a second. Okay, burn's complete. And it looks fine. Actually, yeah, now it's fine. If not actually sure why it's changing there between, it's because it's changing between the sun and Mars. But as long as it's referencing Mars, I don't know why it's changing like that, but as long as when it's referencing Mars, you can see that our PEA at Mars is negative 3,000. But what you can do at this point, if you need to, like let's say it was positive 1,000, change over to linear translation, and then use forward backwards translation to make any adjustments that you need in order to get that PEA down to where you actually want it to be. So that's it. Let's see how we're doing on fuel. 550 meters per second. So we've got more than enough fuel to get all the way to Mars and do a runway landing. Since we do have a little bit more time left on this video, I will go ahead and warp time forward to head off to Mars. That way we can, not have a video that's so short. But basically, when you're using IMFD, you don't really have any mid-course corrections to make up until the point that you actually get all the way out to Mars. Here again, what I like to do is warp time forward until the HUD spins around to the negative position. This is something I started doing recently. Once it's all the way negative to the 180, then I come back to real time, kill rotate, then I'll warp time forward at 10,000. You get a nice view of wherever you're coming from, whether it be the moon or Mars or Earth or whatever. You got it in the rear view mirror now. And we can warp time forward at 100,000. Once I'm at orbit sun, then I do what Dimitri taught me, which is to wait until the HUD spins around to the prograde position. And once it gets around to prograde, then I come back out of time warp and get it basically right at prograde. Then kill rotate. Now when you warp time forward to 100,000, it holds really steady, at least on the vertical axis. The horizontal still kind of swings around a little bit, but it's fine. But you can see now we're warping time forward, and our PEA it's going to oscillate a little bit. But what you'll find with IMFD when you're going to Mars is that it'll oscillate out, but then it'll come back down. So by the time we get really close to Mars, it'll be pretty close to the number that we originally started with, which was negative 3,000. So the fact that it's going up right now, don't worry about that. If there is any concern at all, at the very least, don't worry until it starts coming back down. So it's fine that it's going up, but you'll notice it'll top out here at some number, and it looks like it's getting ready to top out. Now it's heading back down. So if I were going to do any kind of mid-course correction, I would at least wait until the PEA was coming back down and reaching its lowest number. But what we'll find here is that we'll be at Mars probably by the time it bottoms out. I don't think it'll bottom out and go back up a second time. I think it'll just continue to go down until we get to Mars. Actually, we are going to go out beyond the orbit of Mars a little bit, so it might climb back out a little bit before it comes back down again. We'll see. At any rate, we can just watch our PET to know how long our flight's going to be. And when we're at 10M, that's 10 million seconds, we can kind of do a rough estimate that we are like 86 days out. I think that's what that works out to be. So the point is we've got a ways to go. So we're just going to continue warping time forward. And notice our PEA is still coming down quite nicely. This is where we are at in our orbit around the sun. That's Earth, and Mars is here. No, Mars is here. It's that line's pointing to Mars. And our intersect point is over here. So it's kind of a longer flight. You know, usually I would prefer 180, 190 days, 200 days, something like that. But I think this one ended up being closer to 300. Yeah, the PEA is kind of going back up now, and that's because we're going to be going out beyond the orbit of Mars. But what we'll find is once we kind of reach a point over here somewhere, it's going to start coming back down. So now we're 8 million seconds out, 7.9 and so on. This is our indicator for how much time we have to go still. I've gotten used to this. I was always used to using transx, where I was just looking at the encounter MJD and comparing it to the regular MJD, but this actually is almost easier. Let's check our PEA. It's still going up, but now we're beyond the orbit of Mars, so hopefully that's going to top out here any moment and then start heading back down. We'll see. And if it doesn't, that'll be the first time I've seen that. But it looks to me like it's kind of starting to maybe slow down now. We still have 3.5 million seconds to go. And our PEA is, you can see it's definitely slowing down. We're getting close enough, though. I would actually be a little concerned, and I would actually probably do a mid-course correction at this point, because I don't know that we're necessarily going to lose 7,000 kilometers by the time we get over here in a million seconds. I don't think we are. I don't think I've actually ever seen this before, where I've gone from Earth to Mars. See, we're close enough now that I would definitely want to do a mid-course correction. We're not within 0.1, but we're only 600,000 seconds away, and our PEA is 7.7. So, yeah, okay, well, first time for everything. So what I would do here would just be, we're actually kind of facing Mars right now. I can see it right there. But I would just tap translation thrusters. Let's see, we need that helps, and so basically outward is what we're looking at. And by doing it out here, you know, obviously we're saving a lot of fuel. We're not gonna, if we wait till we're too close to Mars, then it's gonna cost us a bit more. But I'm only using translation, and this can't be, you know, I should have brought up burn time calculator to calculate it, but this can't be more than, you know, like 5 meters. We could have waited till we were within 0.01 of Mars, which is normally when I would do this, but I could tell that it just wasn't trending in the direction that I wanted, so we're going to do it here. Now I'm at this number. I'm going to warp time forward at 10 or 100 to see what this is doing. Let's even go to 1,000. Still kind of going up, so let's bring it down a little bit more. And this should really be about the only mid-course correction we need. I actually held the button down too long. I'm guessing that's all the mid-course correction that we need. By the time we get over to Mars, actually let's go a little bit higher than that. By the time we get over to Mars, we should have a PEA that is close enough to what we would normally want that we don't have to do anything else. But let's find out. We still got a little bit of time left on this video. See, it's kind of going up a little bit. That's why I went a little bit on the low side. Watch the PET so we know how far away we are. And you can also know when the altitude gets down to 2 point... Actually... I'm trying to remember what the number is. I don't remember off the top of my head. Anyway, we'll warp time forward until we crash into Mars. Oops, that was my mistake. Let me see if I can correct that. I was looking at the wrong part of the screen. I didn't mean to back up a month. I just want to back up like an hour or something. I screwed it up. Anyway, you would normally come out of time warp, you know, when you get within the gravitational influence of Mars and then do your landing. But again, this flight wasn't about the entire mission. It was just about showing that setup there at the moon, how to set it up, how to get up off the moon. Then once you're in orbit around the moon, there's some additional setup that you have to do. Then you want to go back to the Earth, and on the way back to Earth, the important thing to do is to keep that relative inclination at a low number. And then when you get within 1,000 seconds, 1,500 to 1,000 seconds of PET at Earth, make sure your relative inclination is kind of counting down at the same rate as your time to the periapsis. Then set up your maneuver in IMFD for actually completing the burn to go out to Mars. In this case, our burn was a little bit high. It was like 600 meters per second, and that's just because the timing that we left wasn't quite right, or wasn't ideal, I should say. If you leave at a better time, I think you can complete the burn for going out to Mars for like, I think it can be like 400 meters a second, or maybe even a little bit less. I can't remember off the top of my head what the very best is, but any case, that's how you do it, and it's really useful. It's really fun to set up, and once you learn it and are able to execute it repeatedly, you'll have a lot of fun doing it. And you can go anywhere in the solar system using this method. It doesn't just work for Mars. It doesn't just work for Venus. You can go anywhere. The hardest planet in general is Mercury. And doing this method to go to Mercury is going to be more challenging than it will be for setting it up for Mars. And that's because when you get in toward the sun, the planets are moving a lot faster. They're going around the sun really fast, Mercury especially because it's the closest. So the timing aspect is trickier with Mercury. There's a whole lot of reasons for that. Not only is it tricky to go from the moon to the Earth to Mercury, but just going from Earth to Mercury in general is tricky because there's only a good opportunity about every 7 years to make that flight. So when you add in the complication of starting off on the moon, and you have to work out the timing for the moon to Earth and Earth to Mercury, it's tricky. So that's going to be it. So that's it for this series. I very well may do another example yet, because I just like examples. I think it's good, you know, like again when you're in math class, you know, your teacher teaches you how to add 10 and 10, and then that's not all you learn. You get a whole worksheet that says, all right, now do 50 examples of 12 plus 14 and 6 plus 9 and 123 minus 30. You get a ton of examples. So I think that's the best way to learn. So I might do another example of this. If you like the series, like the video. If you didn't like the series, don't like the video. Subscribe to the channel if you're not already subscribed. Check for links in the description down below, and I will see you in the next video, series, whatever. Goodbye. Now that we have that, we're basically now just setting up, you know, a standard plan for going to Mars using IMFD. Now, again, I don't do this every day, so let me think about things here a little bit. Now we want to set the TEJ. We're going to go forward with the TEJ just a little bit. Again, just give me a second to process everything. Change the projection. Okay, so once we have the MJD set, we're going to bring up interplanetary MFD on this side also, and we're going to bring up the orbit eject program, and we want to actually share this side first. I forgot to do that with this side, so 1, and we want to connect the orbit eject program to the course program. So instead of being higher orbit, we want course. And now we can, there's a few steps here, so just allow me to think, please. We're going to set the TEJ to 0 because it starts off at 876,000 seconds. That's way too much. What we actually need is we just need the TEJ to be like, you know, in a few seconds from now. So we can probably go to a 10x adjustment, and we can swing that forward slowly. Watch that blue line, and what we're looking for is the minimum dV. Now we're going to go down to a 1x setting. So whenever the dV is at its lowest, that's how we know we've got a sufficient TEJ. And ideally, in a perfect world, it will be when we're right there at from the time to do the burn, and we need a lot of that time. So let's go ahead and get started. I'm going to bring up IMFD on this side. Rather, we're going to go to the menu, and we're going to go to course. We're going to go to target intercept, and we're going to target Mars. And for the MJD, we're going to put in the MJD that we get from TransX in stage 2, which is the encounter MJD of 58498.1401. That's what we want. That's what we want here, and we can just press set 58498.1401, and now we're done with TransX. We don't need it for anything anymore. But what I will do is I'm going to jot down that eject date, because a lot of times I have to reset something in IMFD and then I forget what the eject date is. So let's write that down. 58498.1401. We don't really need all those decimal points, but we'll have them anyway. Okay, welcome to another Orbiter 2010 video. And this video is going to be a continuation in the Moon to Earth Sling Out to Mars video series that I'm doing. Again, this is not going to be a full mission. I'm just explaining the setup process and how to execute this flight. Once we've completed the ejection burn to go out to Mars, then everything from that point forward is just standard Earth to Mars stuff. There's nothing new about that, so we don't really need to worry about all the actual trip from Earth to Mars and mid-course corrections and landing on Mars. All that is that's all just standard stuff. The tricky part is setting up the flight from the Moon down to the Earth, and then once you get to the Earth, how do you do the ejection burn to actually go off to Mars? And that's where we're at right now. So if you're following along with this video series, great. If you happen to be finding this video for some reason as your first one, this is actually part 4. So make sure you go back and watch the first 3 parts first, otherwise this isn't going to make any sense. Let's go ahead and switch camera views here, pick up where we left off. We're about 1,200 seconds away, periapsis. But that won't always be the case, and it won't always be the case because sometimes your burn, sometimes you don't arrive at the Earth at quite the right time, which means you didn't leave the Moon at quite the right time. But it looks like we did okay here. So the dV is lowest right at that point. Now I want to check the EIN, and the EIN is showing that it's negative 0.05. We can adjust the EIN by changing the MJD, the arrival MJD, on the interplanetary on this side. So we're going to come over here to the TIN. We're going to go to a 10x adjustment because this is a kind of like your hyper or ultra setting. So if we leave it set to 1, then it's going to be too small of a change. So we're going to go to 10, and we're just going to bump it forward or backward until the EIN is 0. Looks like, let's see, we can even go to 100. Okay, now it's down to negative 0.01. So let's go down to